Hi, we're Team Drone-to-Ground Communications using software-defined radios, a multidisciplinary senior design team in the Kate Gleason College of Engineering. We are a team of 5 engineers: Ethan, a computer engineer; Prosper, another computer engineer; Brian, an electrical engineer; Robbie, an electrical engineer; and Mikey, a mechanical engineer. Our client is Dr. Rahbari and the Wireless and IoT Security and Privacy, or WISP, lab. Dr. Rahbari wants to set up drone and cybersecurity-related research, but had no robust way of letting the drone carry the software-defined radio, or SDR. The vibrations, movement, and possible crashing of the drone suggested the need for a more complex solution in which the enclosure can be tested to ensure the system will still work under real-world conditions. As such, the key goals of this project are to develop a secure enclosure for the SDR, computer, and power supply that must power this payload to support a flight time of at least 20 minutes. Testing with the SDR must also be performed to ensure that the enclosure does not interfere with communications. Careful selection and organization of cables alongside custom 3D printing and manufacturing allowed us to meet the power and weight requirements of the payload, according to datasheet information. We did this because the drone was not yet flight ready, so only ground testing could be performed. The enclosure is designed to hold the SDR used for communication between the payload on the drone and a base station. Thanks to the modular nature of the design, shown by the various mounting holes, additional sensors may be attached. This information is processed by the included Jetson Nano computer, which controls and sends data to the SDR. The enclosure features carbon fiber rods for component and drawer support, as well as carbon fiber panels. Aluminum was used for brackets and other rods. ABS and nylon 3D prints were used for additional connection support, as well as custom enclosures. Our project successfully enables the WISP lab to conduct research in areas of interest, such as cybersecurity and drone-related applications, including traffic analysis as depicted here in this animation. In such a scenario, a drone may be controlled to watch an intersection, monitoring cars passing by and analyzing traffic data. Onboard processing enables quick and efficient computer vision algorithms, which ultimately can get sent by the SDR to a base station for reading or further analysis.